And that, friends, brings us to 100% mastered on multiply by one-digit numbers. We're going to back out into 4th grade and continue on our journey. Up next, multiply by 2-digit numbers. It's a nice small one. We should be able to get through this one tonight. We are only 40 minutes in. We're doing great. Let's move along. Multiplying tens. Okay, so this is just the logical next step, right? It used to be take a 1-digit number and multiply it by some factor of 10, but there is something, or some multiple of 10. There is something I really want to point out here, okay? Because notice that when we do 70 times 30, we're kind of adding the zeros, right? There are 2 zeros, and our answer for this, well, 7 times 3 is 21, and then there's times 10 times 10. But you see how, like, up here, by multiplying, we're kind of adding? And I'm going to put a big old question mark on that. And another question mark for good measure. Because we're adding zeros, right? If I was to do, for example, 7,000 times 300, right? The answer is still the same, 21, and then I just count up the zeros. 1, 2, 3, 4, 5. I end up somehow adding the zeros, even though I'm not adding, I'm multiplying. And that is something that I really want to highlight. That's a pattern that gets very confusing later on when we start talking about exponents and why it is that when you multiply numbers together that have exponents, you end up adding the exponents. Well, this is why. It's just that in this case, the exponents are zeros because it's power of 10. We can visually see that by multiplying 2 powers of 10 together, we end up adding the zeros together. It's a bit of a tangent, but I think it's really important to point out. Padma tried to multiply 50 times 40 by decomposing 50 and 40 into multiples of 10. 5 times 10 times 4 times 10. Yeah, that makes sense to me. And in fact, this is indeed exactly what we just did, right? So she took the 5 and the 4, multiplied them together first, A plus so far. Then she took the 2 10s, multiplied them together second, A plus again, you're allowed to do that. So she got 20 times 100. Oh, tripped up at the very, very end, at the very finish line. In step 4, her answer should have been 2,000 instead of 200. Again, easy mistake to make, would not mark it very much down on an exam, if at all. Step 4 is the mistake. And marrying Anakin. 80 times 30 is 2,400. Joe tried to multiply. Okay, so same deal. I am getting a knock at my door, friends. I am going to have to be right back. I don't even have to be right back. I'm going to switch over to bye, but I will be right back. Okay. So 7 times 10, 9 times 10, those are correct. 7 times 9 is correct. 10 times 10, so far so good. Oh, but step 3 is where it falls apart. 7 times 9 is indeed 63, but 10 times 10 is 100, not 10. The answer should have been 6,300. The mistake is in step 3. $90 times 40, well, 9 times 4 is 36. And then again, we're kind of sort of just adding the zeros. 7 times 10, 3 times 10, that's all correct. Aaron reordered it correctly. But it looks like instead of doing 7 times 3, what Aaron probably did was 7 plus 3. And again, this is exactly the kind of problem that I would want to show to another student and see if they could pick out not only where the mistake is, but what was the student thinking to get 10? Because as a teacher, as someone who's been doing this for a long period of time, I know that, of course, what they did was add, right? 7 plus 3 is 10. It makes perfect sense. But it's a perfect opportunity for another student to engage in that critique the reasoning of others standard, which I keep banging on about all the time, and being able to not just point out that 7 times 3 is the problem, but also what was going through the person's head to make that mistake really enhances the understanding of math and the patterns involved. So step 3 is the mistake. Multiply. 3 times 5 is 15, and then boom, add up the zeros. That's multiplying tens.